Hello, physics kids. Mr. Johansson here. I want to go over our physics test, physics exam number 2. So I'm going to go over question by question and follow along. And if you have any questions, please leave me some comments and I'll get back to them. So a moving body. Here's a key. Must. Must. Absolutely must. What does a moving body absolutely have to do? It has to change. Well, does it have to change acceleration or direction to be a moving body? It does not have to. It may do those things, but must, doesn't have to. Does it have to change velocity? Does not have to. Does it have to change position in order to be a moving body? That is key. To be moving at all, it has to be changing its position against some background. So absolutely, moving body must undergo a change of position. All right, in problem 2, a student walks such and such, and what we're looking for is displacement. That's the first word I want to see, because if it's distance, I'm adding all these things together. If it's displacement, some of these things cancel each other out, like 3 blocks south and 3 blocks north brings you right back to the original starting spot. So these two cancel each other out, leaving you 4 blocks west. So that's all you got, 4 blocks west. And that's because it's displacement. Displacement is just interested in where you started, where you finished. If it was distance, that would be 3 blocks plus 4 blocks is 7 blocks plus 3 blocks is 10 blocks. That would be distance. But they're asking for displacement. Know the difference. The approximate height of a high school physics student. Well, this is really asking 2 questions. Do you know what a meter is? A meter is about a yard, about 3 feet. Okay? So if you know that a high school student is, okay, what are your choices here? Well, look at 10 to the 0th meters. That equals 1 meter. That's 10 with the decimal point right after the first 1. So it's 1 meter. How about 10 to the 2th meters? That's 100 meters tall. That would be as tall as a football field. Unusual in a high school physics student. 10 to the 1st meters, that's 10 meters. All right, that's 30 feet tall. Again, I don't know anybody 30 feet tall. How about 10 to the minus 2? That's 0.01 meters. That's a centimeter. That's the width of a pinky. All right, so I'm thinking, nope, 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 nope. So 1 meter, I don't know anybody 3 feet tall, but look at your other choices. This clearly is the best answer. All right, question 4 then. During which interval is the speed of the object changing? Well, look at this graph. It's a distance-time graph. We know that the slope equals rise over run. That's meters over second. Slope is velocity here. So during which interval is the slope changing? Is the slope changing here? No. Is the slope changing here? No. Is the slope changing here? No. Is the slope changing here? You mean this curve, a place where the slope is always changing? Yes, I'd say the slope is always changing here. So here is where the speed of the object is changing. So that would be dE. Question 5. Object initially at rest accelerates at 5 meters per second squared until it attains a speed of 30 meters per second. What distance does the object move while accelerating? Now, you could use VI, you could use acceleration, you could use VF, and then you can look for D. That would be fine. Or you can look at it a different way. You're getting up to 30 meters per second. Started at 0, and you're doing it increasing by 5 meters per second every single second. So ask yourself, how long would it take to be going 10 meters per second? That'd be 2 seconds. How about 20 meters? That'd be 4 seconds. How about 30 meters? That'd be 6 seconds. It would take you 6 seconds to get up to that speed, wouldn't it? Okay. What's your average speed during that 6 seconds? If you started at 0, ended at 30, your average is 15 meters per second. Notice these seconds cancel. What's 6 times 15? Well, 60 and 30 equals 90 meters. So that's how far you went. Notice how similar it is to a drop problem. That's why we do drop problems. Let's look at this. This graph is especially confusing the first time out. So what is the velocity of the object at t equals 1 second? That would be right there. Well, do you see distance time graph? Slope equals velocity. So if I could simply find the value of this slope, I got the velocity. Well, slope is rise over run. So that's 3 meters over, well, the slope ends at 2 seconds. It's no longer the same slope. So 3 meters over 2 seconds is 1.5 meters per second. So velocity of the object then, it must be going 1.5 meters per second. What's the average velocity of the object from 0 to 3 seconds? Well, average velocity equals distance over time. That's 3 meters over 3 seconds. But I thought you just got done saying it was going 1.5 meters per second. Yes, but that's its actual velocity on this slope. But if I'm using the first 3 seconds, well, I need to use that first 3 seconds. And it only went 3 meters in that 3 seconds. So the average then is just 1 meter per second. During which time interval is the object accelerating? Well, acceleration means change in speed. So when is it changing speed? Slope is velocity. I see no change in slope, no change in slope, no change in slope. Here the slope is clearly changing. So that would be an acceleration. That would be a change in velocity. So that's between 3 and 4 seconds. How far is the object from the starting point at the end of 3 seconds? Well, 3 seconds, we went 3 meters. This is a directly read graph, nice and easy. During which time interval is the object at rest? Right here, notice it is not changing its displacement at all. So between 2 and 3 seconds, it is at rest. Next question. I also love this question. A toy projectile is fired from the ground vertically upward with an initial velocity of 29 meters per second. The projectile arrives at its maximum altitude in 3 seconds. Did we need that 3 seconds? Absolutely not. That is information that you should be able to figure out very quickly all by yourself. Consider, if I throw an object up, let's do it on the bottom of the page here. If I throw an object up and it's starting at let's round it to 30 meters per second. After 1 second of flight, what's its velocity? Remember, it's accelerating. All right, it's accelerating. The acceleration is downward at 10 meters per second every single second. That means if I threw it up and it was starting at 30 meters per second, after 1 second, with this acceleration due to gravity, I will have reduced its velocity by 10 meters per second. So after 1 second of flight, it's moving now 20 meters per second. What's its speed after 2 seconds? Well, I've removed another 10 meters per second in that next second. So after 2 seconds, it's only going 10 meters per second. How fast is it going after 3 seconds? Well, after 3 seconds, I've removed another 10 meters per second. So after 3 seconds, it's moving at 0 meters per second. And then it's going to start falling. And in the first second, it will increase its velocity to 10 meters per second. In the second second, to 20 meters per second. In the third, to 30 meters per second. See how it's all beautifully symmetric here? Okay, now we can do this problem. As the projectile rises and then falls back to the ground, what happens to its acceleration? Well, when it leaves my hand, it is done with its acceleration caused by me. After it leaves my hand, everything that happens is due to gravity. Nothing else is holding it, so acceleration absolutely remains the same. In order for the acceleration to change, something else would have to be tugging on it. It's only gravity tugging on it. On its way up, gravity's slowing it down. On the way down, gravity's speeding it up, but it's only gravity. What is, oh, look at this word, the displacement of the projectile from the time it left the ground until it returned to the ground. So I throw it up, and then eventually it's right back where it started in my hand. Its displacement, therefore, is 0. Now, if they asked the distance, that would be different. Then you'd have to figure out the distance up and add that to the distance down. But displacement, where you started, where you ended, period. So what's the greatest height the projectile reaches? Well, how about that? It's a 3-second drop problem. Hope you can see that. It turns into a 3-second drop problem. So how do you do that? Well, it starts at what? Starts at 0, ends at 30, averages 15 for 3 seconds, gives you 45 meters. Now, when you do the actual calculation, with 9.8 meters per second squared, it ends up being 44 meters. Do you see any other choice, though, that is even close? Nope, couldn't be. All right? And if you consider that it's moving for 3 seconds, sometimes people answer 87 meters. Absolutely not. Why not? Well, 29 meters per second times 3 seconds, that gives you 87 meters. Absolutely. But is it maintaining that speed? Is it maintaining your 29 meters per second? Of course not. It's getting slower all the time. So there's no way it would be going 87 meters in that period. What is the velocity of the projectile when it strikes the ground? Well, we're right back here, right? It was going 30 meters per second up, 20 meters per second up, 10, 0. On its way down, 10, 20, 30. So its velocity is going to be exactly the same as it was when it began, only in the opposite direction. So if we consider up positive, we consider down negative. Excuse me, which paragraphs represent the same motion then? Well, we've got to remember, distance time graph, the slope is velocity. The slope is velocity. So here, what's the slope? 0. Does that look right? Velocity is increasing. The velocity here is, you don't have a velocity. Velocity is 0. So this would not have a velocity. Doesn't make sense. Here the object was going quite fast to begin with and is slowing down. Velocity is decreasing. What do we see? Velocity increasing. Can't be the same. Here we have a constant velocity. No change in velocity at all. How do I know that? No change in slope. It's a negative slope, and there's no change in the slope. And here we just have a constant velocity. Doesn't work. Here we have a constantly increasing slope, so a constantly increasing velocity. And here, look at that. We have a constantly increasing velocity. I think we got ourselves an answer. Well, that's the test this time. I hope some of those things helped. Some of these questions you will see again. Some you will see in different ways. Well, thanks for watching.